So very good morning to one and all. So in today's class we are going to discuss about the phase diagram. This is the continuation of the previous class, that is phase rule. So the application of phase rule is nothing but phase diagram. So that we are going to see today. So myself is Jagapriya, Assistant Professor in Chemistry, Manipulative College of Engineering and Technology. So we have already seen the phase rule, that is Gibbs phase rule, and today we are going to see about phase diagram. Phase diagram is a graphical representation of physical states of a system under different conditions. Phase diagram is obtained by plotting a graph with 1 degree of freedom against another. So what is a phase diagram? Phase diagram is used for explaining the different physical states of the system. We know the different physical states, that is solids, liquids, and gases. So the different physical states of the substance under different conditions. What are the phases which is available in different conditions? Thus, that can be explained by means of phase diagram. Now, how to draw this phase diagram? Phase diagram is obtained by plotting 1 degree of freedom against another. Now, let us discuss the phase diagram of one system in detail, and that is the application of phase rule. And we are considering the system here as water system. A water system is an example for one component system because the chemical composition is H2O, so it is an example for one component system. So we are going to discuss the phase diagram for water system with the help of this phase rule. Now, as we all know, water exists in three possible phases. It is solid, liquid, and gas. It is vapor. Hence, there can be three forms of equilibrium available. So that is solid to liquid, we call it as melting. Liquid to vapor, we call it as vaporization. And solid can be directly converted to vapor, which we call as sublimation. Now we know each of these above equilibrium, each equilibrium involves two phases. One solid, one liquid, one vapor, one solid and one vapor. So thus, the phase diagram of water system contains curves, areas, and triple point. So we're going to see it one by one. And before going to see it, we are going to see the phase diagram for the water system. So this phase diagram itself will explain everything in detail. That is the importance of phase diagram. Now you can see this phase diagram. So this phase diagram is having curves, areas, and points. So let us see the curves. The curves are OA, OB, OB dash, and one OC. Maybe it is a line, but I call it as curve here. So altogether we have four curves here. That is curve OA, curve OB, curve OC, and curve OB dash. Okay. Then I have areas here. It is area under the curve BOC, area under the curve AOC, area under the curve AOB. Like this, three areas. So under the area BOC, we have only one form or one phase, that is solid phase. Similarly, under the curve AOC, we have only one phase, that is liquid phase. Similarly, the area under the curve AOB, we have a single phase, that is vapor phase. So all the areas contains only one phase. Now let us go into the curve. Let us see the curve OC. So here, one phase gets transformed to other. That is solid ice getting transformed to liquid water. So along the curve or along the line, two phases will be in equilibrium. So solid ice as well as liquid water. So two phases are in equilibrium. Okay. Similarly, along the curve OA. So I call this curve as vaporization curve or vapor pressure curve because along this curve, liquid water as well as vapor are in equilibrium. So this is vapor pressure curve. Similarly, you have another curve called OB. And this is called the sublimation curve because solid is getting converted to vapor. So this is sublimation curve. We have another curve that is OB dash, and that is represented by dotted line, and that is a metastable equilibrium curve. So that we can see in detail during the explanation. Okay. So, and we have one point here, and that point is triple point, which is denoted by the letter O. So the triple point O, where all the curves meet at the point. So that is triple point O. Okay. So this is all about phase diagram. So this is the phase diagram for water system. So with the help of this phase diagram, we're going to find what is the degree of freedom for each entity. Okay. So that helps us to define how many independent variables are required for explaining the system. Okay. So let us go into detail. So first is curve OA. So curve OA is called as a vaporization curve, as I already explained with the help of this phase diagram. So at the curve, there are two phases in equilibrium, that is liquid water and vapor. So here you can apply the phase rule, Gibbs phase rule, which is F is equal to C minus P plus 2. So here C is the number of components. Now it is a one component system, H2O, it is a one component system. So the components is 1 and the number of phases along the curve is 2. Right? Because liquid water and water vapor. So two phases. So the value of C is 1 and the value of P is 2 here. Therefore, when applying it in the formula, we will get F is equal to 1, which means we are in need of only one independent variable for this explaining the system in detail. Okay. Then OB. So the curve OB. Curve OB is called as a sublimation curve. Okay. So solid getting converted to vapor. So along the curve, two phases are in equilibrium. That is ice and vapor, solid ice as well as vapor. Okay, but it is a one component system. It is a one component system. Therefore, the number of components C is 1, and the number of phases here along the curve is 2. So when applying this in the phase rule, we will get F is equal to 1, which means again we are in need of only one independent variable to explain the system in detail. Okay. So next is curve OC. So curve OC is called as the melting curve of ice. It represents the equilibrium between ice and water, that is solid and liquid. Okay. So here two phases are in equilibrium. So as usual, it is a one component system. Water system is a one component system. So the value of C is 1, P is 2, and therefore the value of F becomes 1, which means it only one independent variable is enough for describing the system. And then we are coming to the point O, that is called as triple point. So the triple point O is a place where all the three curves meet. So that is called triple point. And this is a point at which all the three phases are in equilibrium. That is solid ice, liquid water, and the vapor. All are in equilibrium. Okay? So apply this in the phase O. So it is a one component system and the number of phases here is 3. So while applying this, we will get F is equal to 0, which means the system is non-variant. What does it mean? It means we don't want any independent variable to explain the point at which all the three phases are in equilibrium, which means the pressure is 0.00. If the pressure is 4.58 millimeters of mercury and if the temperature is 0.0075 centigrade at this particular temperature and at this particular pressure, the system will be in equilibrium with all the three phases. That point is called as triple point. Similarly, let us go to the one more curve which is left behind, that is metastable equilibrium curve. So the metastable equilibrium curve is called OB dash, which was represented by the dotted lines. Here, supercooled water and vapor are in equilibrium. So what is the supercooled water? Supercooled water means it is possible to cool the water below 0 degrees Celsius, but still it will be remaining as water itself. So such water is called as supercooled water. So supercooled water is unstable. That's why we are representing the line by a dotted line. Okay, so that water can be converted into solid even by a slight disturbances. So it is called supercooled water, and the metastable equilibrium curve, the supercooled water and vapor will be in equilibrium. Then the areas. So already I told you there are three areas under each curves. So area AOC, BOC, and AOD. So these are the areas at which only one phase is present. So the number of phases in the areas is 1, and it is a one component system. So when we apply this phase rule, the value of F becomes 2. which means we are in need of two independent variables to explain the system in equilibrium, which means there is no system in equilibrium there. Only one phase is there. Nothing is in equilibrium. So at that particular area, only one phase will be available in equilibrium. So we are in need of both temperature as well as pressure. Only then we can explain the particular system there. That's all about water system. Hope you all understood about this water system in detail. So water system is an one component system which makes use of the Gibbs phase rule F is equal to C minus P plus 2. So thank you for your patience and thank you all.